upside down. This is the first video for Chapter 7, 7.1a, or 6.1 if we are in the 6th edition. And in this chapter we're going to talk about matrices, and so this is kind of an introduction to matrices, and we'll talk about some of the notation and things that you need to know about matrices. So a matrix, the plural is matrice. A matrix is any array of numbers. So in this one you see that we have these numbers 2, 5, 0, 3, negative 1, 7. Okay, we say the size of a matrix by the number of rows first, right? So there are 2 rows here. So this is 2 by the number of columns, or in other words, how many things are in each row. And so that would be 3. So this is a 2 by 3 matrix. Totally different than if we have a 3 by 2. Okay, so this one has 3 rows, and each row has 2 terms, or there's 2 columns, right? So this is a 3 by 2. So we really can have them in any size, okay? They don't have to have multiple rows. In this first one, there's only 1 row, but there are 3 things in each row, so this is a 1 by 3. In the second one you see here, there are actually 4 different rows, right? So it's counting down how many they are going down. This is 4, but there's only 1 thing in each one, so this is a 4 by 1. So the size of the matrix is going to matter when we start doing things with it in the next section. So we do want to know what we're talking about when we say that something is a 4 by 1 or a 2 by 3. The only time it wouldn't matter is if it were square, right? A 3 by 3 would have 3 rows, 3 columns, and it doesn't matter the order that you say them in. Any other time, the order would matter. When we name a matrix, we're usually going to use a capital letter, okay? And it's most often from the beginning of the alphabet, although not necessarily. So this, I'm saying, is matrix A. Okay, so when we name the pieces of it, we name it by what row and what column. And just like when we named the size, the rows came first, right? So I'm going to call them with a small a, since this is matrix A. So A, and then sub 1, comma 2 would be the term in matrix A and the first row, second column. So first row, second column would be right here, right? First row, second column would be this number 1. Okay, so if I wanted to do the third row, fourth column, then I would be looking at third row, fourth column would be this number 8. So by having this notation, I can pinpoint any term that I want to pinpoint in this matrix. Okay, so if I wanted to describe where the 6 was in this matrix, I would say that it's in the second row, fourth column. Oh. Okay, and so that's the notation that I would use to talk about whatever's inside the matrix. So the main purpose of a matrix is to kind of organize our information. So if you look at, like, this is an example of what a scientist might do. This one happens to be organizing the whales or something. And you can see that we can use the rows and the columns to keep track of things. Like the males here, if I added up all these in the male in the first row, which is the males, whether they're immature, juvenile, or adult, then I have a total for how many males there are, right? And if I added the second row, that would be how many females there were. If I wanted to know something about juvenile, I could add the juvenile ones, right? And even though I have it split, have my information split into male and female, when I add that column, then that tells me how many juveniles there were total. And so that's the usefulness of a matrix. We can keep track of a lot of information in a matrix by where it's placed in the matrix, and we don't have to have so many descriptions and so many things. We can do it, and it's especially been great with computers and stuff, because computers can just store this information in a matrix, just great. And it's really useful to have things in a matrix. Okay, so we're actually going to use a matrix to do something that we just did in the last chapter, but it'll be another way of doing it. And even though matrices are probably new for a lot of you, and you probably are going to prefer to do it the way we did it in the last chapter, if you give it a chance, I think you'll find that matrices can be very useful. So I'm just going to show you how we're going to set up the matrix, and then in the next video I'll show you what we're going to do with them. Okay, so we are going to do what's called an augmented matrix, and I only tell you the name of it because we might see it described or something. So an augmented matrix. Okay, so we're going to get it from equations. So this would be like we're solving a system of equations. So if this were our system, 2x minus y equals 5, and x plus 4y equals 7. Okay, now we've done some like this. You actually know too, you could graph it and get the answer from a graph. You could use substitution and get the answer from substitution. You could use elimination and get the answer from elimination, right? You could do it in all those ways, but now we're going to do it with matrices. And with only two variables and two equations, maybe matrices, maybe it doesn't help you that much. But when you start having 3 equations and 3 variables or more, then matrices can be really helpful. Okay, so we're going to just look at the matrix as the first equation is going to go in the first row, and we're just going to write the coefficients. So it's just kind of a shorthand. Okay, we kind of think of this last column, the answer column, as a little bit different than the others, because it's kind of, that's why it's called augmented. It's because we're tacking it on. There's other things we'll do in the next few sections that will just use the coefficient matrix and not the answer matrix. So when we use the answers too, all stuck together in one matrix, we'll call it an augmented matrix. And the second row is going to be the second equation. So really, I can put just these numbers down, and I know that everything in this row has an X with it, right? In this column, sorry, in this column. Everything in this column has a Y with it. And then there's the equal, and then this last column is the answer column, right? So I've arranged it so that I can keep track of it like that. Okay, so an augmented matrix, we're going to solve this system using some matrix, using things that we can do with matrices, okay? Let's do the quiz problem. Here are the quiz questions for this first video. There's 2 of them. Give the size of this matrix, matrix A, and also tell me what number is A sub 2 comma 1.